Hello, I'd like to introduce you to Olivine Technologies. We're developing an olivine-based sequestration reactor for the permanent storage of CO2 using olivine. Our story starts with the aqueous mineral carbonation test work that's been done throughout the world over the last 25 years, which is focused on carbon capture and storage using olivine or other minerals in a water environment. We're also looking at recovery of minor critical metals, and we're looking at a smaller scale applications for companies that are SMEs like distilleries and biogas plants. Our story goes back to the Department of Energy of the United States. Between 1999 and 2005, they commissioned a 6 year long study, experiments, work, and then a feasibility study on the use of carbon sequestration as a solution for coal power plants. They engaged the Los Alamos Institute, which looked at capturing 1,000 tons of CO2 per hour in a huge 10,000 cubic meter reactor. However, the process was closed down because the cost was $54 a ton at the time. This was considered infeasible. Of course, they also had issues in developing the reactor, which they were refining and looking at solutions. We've come along and we're looking to adapt this same technological development to much smaller scale applications. We're going to be technically much more feasible, much more cost effective, and modular. We can upscale fast and process very economically and successfully. Our clients or our customers were targeting, first of all, the biogas sector. These are distilleries and biogas plants or ethanol plants that release biogenic CO2 into the atmosphere. They're not penalized for that, but they're letting something very valuable escape. By capturing it and storing it, they can become carbon negative, they can reduce their scope 3 emissions, or they can sell the carbon credits for financial benefit. We're looking actually at producing reactors that capture 500 to 1,000 tons of CO2 annually. Comparing to the Department of Energy, we're 16 to 8,000 times smaller. But we've also got the potential to recover critical metals, especially nickel, about 4 kilograms, $60 worth per ton of CO2 that's captured. Our reactors are modular, so we can have several reactors in the same place working to satisfy the carbon emissions needs or solution needs that companies have. Our primary focus, of course, at the moment is in the UK because that's where we're based, in Ireland and the UK. And what do we see? We see that there is a national carbon storage solution, which means pipelines going into the sea and filling up dried out reservoirs. However, the access points to these are small and far between. A huge number of companies are disadvantaged, as one can see on the smaller maps on the right and the left. Biogas, quite a lot is in the south, in Northern Ireland. Gin is in the south and the north in the Scottish distilleries. Our client market is quite big because we can bring a permanent storage, economically feasible solution to the client, rather than the client having to figure out how to successfully transfer CO2 to a storage access point, which probably will not provide SMEs with access. At the moment, we're focusing on optimizing this process, especially the recovery of metals, and particularly we're focused on the amorphous silica potential of $100 to $300 per ton that's produced out of the residue. We're focused also on permits and DIA health and safety compliance, and we hope that in about 3 years' time we're going to have an up and functioning TRL level 9 process. Our team comes with a lot of experience in greenhouse gases, in environmental, in mineralogy, and in reactor development. Thank you very much for listening to our presentation and look forward to working with you.